Hey everyone, let's answer some limit questions based on the techniques that we've learned in class today. Let's look at number 1, right? Limit as x approaches 2 of x squared minus x minus 2 over x squared minus 5x plus 6. Now remember, the first thing we always like to do with this sort of problem is plug in the number, right? In this case, plug in 2. Let's see what happens if we do that. Well, if we do that, we're going to get 2 squared, we're going to get 0 on the top, and looks like 0 on the bottom, right? That happens. Okay, so maybe what we do, remember that means we have an indeterminate form, maybe what we do then is we try to address this indeterminate form by factoring. And if you remember, we've actually done this in class, at least that top part. We've seen that expression before, so we can factor that. And then on the bottom, right, you might notice that we can factor that into x minus 2 times x minus 3. And then, eureka, we can cancel. And then we're left with 2 plus 1 over 2 minus 3. Whoop. And that's the same as negative 3. Right? Just want to note, by the way, that I removed this limit as x approaches 2 once I plugged in 2, right? That's how that works, okay? Now, second, let's take a look. Same sort of problem, except it's the limit as x approaches 3. Now, we already know from the previous problem, right? Because it's the same exact expression, it's just x is approaching a different number. It's approaching 3, right? In this case, right, we'll factor it the same way we did before. But what happens is, at this point, we have a situation where we have 4 divided by 0. And you know what that means, right? We're going to have infinite limits. But what we have to do is look at the left and right-hand limits. Okay? So I'm going to speed through this a little bit. So I'm just going to write that. You don't need to write this down, by the way. But just so that we're crystal clear about what we're going to do, we're going to look at the left-hand and right-hand limits. So I'm just going to knock this out very quickly. Since the left-hand limit, I'm going to write this abridged form. Let's see. X is a bit less than 3, so x plus 1, okay, that approaches 4. X minus 3 is a bit less than 0, so I guess this approaches negative infinity. And then we approach 3 from the right-hand side, right? We have, that's going to positive infinity, right? Because the top and the bottom are both positive. Right, we see that the limit as x approaches 3 of this whole thing does not exist, okay? Right, so again, just to show you that, indeterminate forms, sometimes you get an easy answer, like negative 3. Other times you have a more complicated situation where you get a limit that doesn't exist. Okay? For number 3, right, let's take a look at this guy, right? If you plug in x equals negative 1, you're going to get 0 over 0, right? So again, indeterminate form, more than meets the eye. So let's do a little bit of factoring, right? Factor out maybe an x squared on the top. The bottom, you might notice it's x plus 1 times x plus 1. We get some good factoring. Another situation, though, where this leads to a situation, right, we have 1 over 0. We have to do this again, right? We have to do the left and right hand stuff again, right? So look at left hand and right hand limits. All right, well, just as we did before, right? Let's look at the left and right hand limits, right? Limit as x approaches negative 1 from the left, right? Since this limit, okay, now be a little careful, right? Negative 1 from the left, so x plus 1 is a little bit less than 0. The top is always positive, right? So I guess we're getting this limit is negative infinity because the top is positive, the bottom is negative. So we get that, and the limit as x approaches -1 from the right. Here the top is once again positive, but so is the bottom. Right, we again see that the limit, the double-sided limit, as x approaches -1 of x squared over x plus 1 does not exist. Okay? All right, number 4 now. Now, this is a little bit of a weird one. Right, you plug it in, no surprise here, you get 0 over 0. The weird thing about this one is the way that you factor. You might look at the bottom and say, okay, we can factor that. You might look at the top and say, can we factor that? The answer is yes, but it might not be obvious. You might have seen this technique before, you might not have. It comes up every so often. The way that you factor this, again, we keep writing the limit as x approaches 4, because we haven't plugged in 4, we haven't taken the limit yet. You factor out an x minus 4, and then this becomes x squared plus 4x plus 16. Right, and on the bottom, meanwhile, we have x minus 4 times x plus 3. Right, and so here, this is a bit nice, right? Once you see that factoring technique, you just cancel it out, plug in 4, and you get 48/7, right? No biggie for that one. Numbers 5 and 6 are a little bit more involved because of these radicals, right? It requires a different technique. Okay, so we're gonna cover that in class tomorrow, but you will not be quizzed on that.